Okay, welcome back. Now we're gonna try to solve the following radical equation. Okay, square root of 1 minus x plus square root of x minus 1 equals 1. Okay, I see most of the people that do what they do is they start by squaring everything and they keep working. Okay, so we're not gonna do that. That doesn't work in this case. And here we need to see that before we proceed, we need to see what we can do here. We need to see where these quantities are defined. So we have this square root. This is defined when 1 minus x is bigger than 0. The second one is defined when x minus 1 is bigger than 0. From the first part, we get x is less than 1. From the second part, we get x is bigger than 1. That means x equals 1. That means the domain of definition for this function is just 1. Okay? Before we solve anything. So this is defined only for x equals 1. And when we plug x is 1, we get 0, 0 equals 1. That means 0 equals 1. That means the equation has no solution. Okay? So we don't need to keep solving. But this problem, we want to learn something from it. Okay? So that's why we're going to do it in many different ways. Okay? So here, note that the domain is just 1. This function is defined only when x is 1. Okay? We're going to do one more thing. We do it graphically, and we're going to square both sides to see where we get. So to solve this one graphically, let's go back to see what we mean by that. So assume that we are given this function, the graph of this function f, and another function g. Okay, so these two functions, they meet at this point. Here, the projection on the x-axis, let's call it a. So this is our x-axis. This is our y-axis. So this point is the solution of the equation f of x, g of x. Okay, and we see that these two functions are defined everywhere. So project f and project g on the x-axis to see where they are defined. So we see that both f and g are defined everywhere. Okay, in this case, in our graph. Okay, remember that the domain of the sum of two functions is the intersection of their domain. Like here, the intersection of this one, the domain is this one. This function is defined when x is less than 1. This is defined when x is bigger than 1. And that intersection is 1. That's why this function is defined only when x equals 1. This function defined for one value only. Okay? To see or to solve it graphically using this technique, we need to write this one in this form. We need to construct two functions, f and g, and graph them. Here we can graph these ones. It's very easy because we know how to do the square root, the base function of these two functions. So let's use square root of 1 minus x equals 1 minus square root of x minus 1. Okay? So this is our f, and this is our g. And we will see if they intersect. That means the point on the x-axis where they intersect is a solution of the equation given. So let's graph. First, let's graph g1 minus x. So we know the graph of g of x is like this. G minus x is like this. G f of minus x, f of x. But with this one, so we shifted a bit. We shifted 1 unit. So this is, it's gonna be parallel if you accept that. So this is square root of 1 minus x. Okay. The other function here, we're gonna graph it. So this is this part, square root of x minus 1, is just the square root of x shifted 1 unit. So it's here. Okay. But with the minus, this is minus square root of x minus 1. But when we add 1 unit, we shifted up 1 more unit. Okay? we shift it up one more unit. So here this is okay. So this is the graph 1 minus square root of x minus 1, the one in green, okay? And this is the graph of square root of 1 minus x. We see that they only define for one point, which is 1. That's what we get doing it algebraically. They don't intersect. That means this equation has no solution. Okay? So this is a graphical solution for this radical equation. That means they don't intersect. And they are both defined for one value only, which is 1. Okay? So this is the square root of x minus 1. This is square root of x minus 1. This is square root of minus square root of x minus 1. This is 1 minus square root of x minus 1. So the one in green is our function g of x. Okay? And the one in red is our function f of x. We see that f of x equals g of x gives no value. Okay? They don't intersect. Look, this is our function. This is our function. You put this one in red to see this one clearly here. Yes. Okay? Another thing is, what if we square both sides? That's what we do all the time, yes? Let's square both sides. To square both sides, we need to remember that square root of a plus square root of b squared is a plus b plus 2 square root of ab. So we're gonna use this one here when we square with a square root of a is square root of 1 minus x, square root of b is square root of x minus 1. Okay, once we do that, let me get a new piece of paper. So once we do that, what we get? We get 1 minus x plus x minus 1 plus 2 square root of 1 minus x times x minus 1 equals 1. This one gonna go, so we get only 2 square root of what? Minus x minus 1 squared equals 1. Here you see that we have a problem. Okay, so let me make it bigger. 1 minus, or it's the same. So 1 minus x squared is the same as x minus 1 squared, but with the minus. So here, this number, the 1 minus x squared is always positive. But with this minus, it's always going to be negative, except when x is 1. It's going to be 0. So when x is 1, we get 0 equals 1. That means no solution. Okay? So this is a good way to learn that it's not always good to square everything. No. It's not good to square everything. You just check where your function is defined. Think of the equation as a function and find its domain. So sometimes you just stop, like we did here. We said that this one has one value, defined for one value, and we stopped without doing all the work. Okay? So it's good to learn. Another thing is that when we have the square root of x and we square it, we get x. When we have x squared and we square it, we have to be careful. We have the absolute value. Okay. So that's why we need to be careful when doing these two operations. It doesn't mean all the time. It's not true. It's true for one case, when x is positive. So here, when x is positive, the absolute value of x is just x. So we have this, we have the square root of x squared is equal to the square root of x squared. So when x is positive, we can do it. Because sometimes you have minus 3 squared, which is 3 squared. It's negative. Okay? So this operation is through only when I said when x is positive. So we're gonna be careful about that. Thank you.